Once you plot it, okay, then you can see the point where the two lines are meeting. Okay, they meet means what? When the two lines are meeting, it means what? Huh? There is no Q. Okay, meeting of two lines means no Q. Clear? Okay, so the time where the two lines are meeting, you can find out this time, and this is the time which you need to clear the queue. Okay, the time which you need to clear the queue, which is around 1 hour. Around 1 hour, you can find out the exact value. Okay, so the first thing you can know from the graph is how much time you need to clear the queue. Okay, and obviously you can also see when the queue happens. Okay, here there is only one change, but maybe the two lines were going together, then they changed and so on. So wherever the two lines go separate, that means there is a queue. When they meet, there is no queue. Clear? So you can find out where the queue is, what time. Okay. Second thing is the length of the queue. How long is the queue? So we said wherever the two lines are separated, this is the queue, right? Yes. Okay. So the difference between the two lines gives you how many vehicles are in the queue at any time. So somebody wants to know what is the queue length at 10 minutes. You take the difference between the two lines at 10 minutes. If you want to know at 20 minutes, take the difference. If you want to know at 30 minutes, take the difference. Clear? So difference between the two lines. Vertical difference between the two lines gives you the queue length at that time. Okay? Then you can take the horizontal difference between the two lines as well. The horizontal difference means what? It will be time, right? Which time? It will be the delay for that vehicle. It will be the delay for that vehicle. Okay? So for example, I come to 100 and take the time difference between the two lines. Okay? 100 means what? This is the number of vehicles, right? Yeah. So the 100th vehicle faced how much delay? This much. So you can exactly know the delay for each vehicle. What is the delay of the first vehicle? This much. Second vehicle, this much. Third vehicle, this much. 50th vehicle, this much. 100th. Okay. So you can get number of vehicles in the queue at each time. You can get the delay for each vehicle. And you can get the total delay as well. This is the total delay. What is total delay?
From 0 to 60.
Yeah. But total delay is the difference of areas under the two lines. The difference of areas under the two lines. So you have area under this line and area under that line. Okay, area under the arrival line, area under the departure line. Okay, if you take the difference between them, it will give you total delay. Clear? So once you plot the graph, I told you 4 things. Remind me, which 4 things? Yeah, the time where there is no queue. Okay, the time which you need to clear the queue. Okay, what else? Yeah. Total area over total area will give you total 0 in the exam.
The vertical distance will give us the queue length.
The vertical distance will give us a queue length, and the horizontal distance will give us the delay. Okay, this queue length is for a specific time, and this delay is for a specific vehicle. Okay, and the difference of areas gives you total. Difference of areas gives you total delay. Yes. Sorry? Yeah, the pink one. The pink one. For the departure, only the pink one. For the arrival, both. And then you take the difference. So when you take the difference, only the purple, what is it? Blue or purple? The difference is only the purple, right?
Okay.
The difference is only the purple. The total delay is only the purple area. See? You can only see black and white.
Can you show us
He's doing blue and purple.
how do they find the queue length?
Huh?
Queue length.
The difference between the two lines. What is queue? How many people came and how many left? The difference is the queue, right?
Yeah.
So people who came, people who left. The difference is?
No.
Right? Okay. In this example, you can see we have only straight lines. This is linear, right? Arrival is linear, departure is also linear. In this case, the total delay becomes slightly easier to calculate. Okay, we will look at other examples as well where they are not linear, then it will be different. But for the sake of this example, it's very simple. You can take it, the difference of the area can be taken as a right angle triangle. That's it. Okay, if you have arrival and departure both linear, arrival and departure both are linear, then the difference of their areas can be taken as a right angle triangle. What is the area of a right angle triangle?
Half times base times half.
Okay, half base into height, right? So half. Okay. Now how many triangles you can see here? This is a one, and then this is another one, right? So two triangles. We'll take two areas. Okay. The first one, half. Okay. Then I need the base into height, right? Okay. Base is time. How much is the time? 20. Because after 20 the line changes, right? That's why we have two triangles. So the base is 20. What is the height? The difference between them? 80. Okay. How do you find 80? You already plotted them. You can find out the difference between them. Or you can go to the equations. These equations. You already have an equation for arrival. You already have an equation for, sorry, you already have equation for arrival and departure. Okay. So 8 into 20 and 4 into 20. See the difference? This is the height for the first triangle. Okay. Second triangle, now you have to use a graph. Okay, because I want to know this time. Okay, so this is how much now? It starts from 20, I know. Starts from 20 and ends at 60. So the base is 20 to 60, which is 40. Okay, and how much height? Same. Okay, because you cannot take the difference of height here. It's 0, right? Difference here is 0. So you have to take it from here. Clear? Okay. So once you have plotted the arrival and departure, and they are straight lines, then the area between them can be taken as half base into height, the right angle triangle. Okay, where base is the base, the time, and the height is the difference between the two lines. Okay, at that time. Clear? Any questions? Okay. So this will give you how much? How much is this? Now this is what we call it vehicle minutes. Okay, so all the vehicles faced a delay of 2,400 minutes. Total. This is total. Clear? Okay. Any questions? Okay. Another example, still we are doing DD1, deterministic arrival, deterministic service rate, and one channel. But now we have time varying demand and constant service rate. Okay, so which is similar to the previous one. Yeah. But it's different because of the equation. So there is a national park. Okay, do we have a national park here? Do you know the meaning of national park? Huh? What? Which one? Huh? Which one? Ah, okay. Yeah, something like this. Okay. So we have that national park and people start arriving at this park at 5:45. I don't know why. Okay. But you go to gym at that time, right? No issue. Okay. And they have a booth which collects fees for the entrance, okay, and that booth opens at 6 a.m. Okay, so people start arriving at 5:45 and the booth opens at 6 a.m. No other thing to do there in their lives. Okay, so according to the booth processing time, it takes 20 vehicles per minute. The booth can service 20 vehicles per minute. Okay. So each vehicle around 3 seconds or something. Anyways, it is estimated that 20% of the vehicles, now this is funny, listen to this. 20% of the vehicles have priority passes. They are like VIP, they've already paid like extra money to get the priority pass. Okay. So what happens to them? They go from a separate booth, okay, and that booth processes 15 vehicles per minute. The normal one processes 20 per minute. These VIP guys are even slower.
They paid money and they are also slow.
Now you got it. Okay. So this happens, huh? This is life. Okay. The arrival rate of the vehicles is given by this equation. So it's not constant now. It can change every minute. It can change every minute. Where t is in minutes, and the equation starts from or applicable is after 5:45. So the rate at which people are coming, it starts with this equation after 5:45 onwards. It doesn't change. The equation doesn't change, but the rate changes according to time. Okay. Find out the average delay per vehicle for the non-priority vehicles and for the priority vehicles. Average delay. Okay. Average delay. Now remind me, what was total delay? What was total delay?
The area.
The difference between the area under the two curves.
Okay, the difference between the area under the two curves. Okay, so you have to find out that difference, but that will give you which delay? Total. For average, we should do what? We have total. I need average. What we would do?
By the number of vehicles.
By the number of vehicles. Clear? Okay, so we should find out the average, total delay, which is the area between the two curves, and then we will divide by the number of vehicles. Okay, so first of all, I need the equation for number of vehicles arriving and number of vehicles leaving. Okay, this equation is for the rate of arrival. The lambda equation is for the rate of arrival. Okay. To find out the equation for number of vehicles arriving, okay, I will integrate this equation with respect to time. To get the equation for number of vehicles arriving, I will integrate the equation with respect to time. Equation is given in terms of time, right? So I will now integrate the equation with respect to time. Okay. So if you integrate this equation, the lambda equation with respect to time, what we will get?
17.2 t minus 0.2 t squared over 2. What is the t? Over 2.
Okay, instead of over 2, we can make it 0.1. Okay, this equation gives you how many vehicles arrive. Okay, then I need the equation for how many vehicles depart. Okay, what is the departure rate? We are doing it for the time being. We are doing it for the non-priority pass vehicles. Okay, so what is the rate for non-priority vehicles? 20 vehicles per minute, right? And if you have to calculate the number of vehicles, then 20 into T. Okay, we don't need to do any because the rate is constant. The rate is like we did in the previous example. The rate was constant. I just multiply with T. Clear? Okay. If the rate is not constant, then we have to take the integral. Okay. Here the rate was constant, 20 per minute. 20 multiplied by time will give you number of vehicles. Here the rate is not constant, so I have to take the integral. Clear? Okay. So I have number of vehicles arrived and I have number of vehicles departed. Okay.
Now we can do all the plot.
We don't need to do the plot. Okay. We will use the equation directly. Okay. But before we do that, I should know how long the queue will take, the clearance time. Okay. At what time the queue will be gone. I want to know at what time the queue will be gone. Okay. When the queue is gone, number of vehicles arrive equal to number of vehicles depart. Okay. So I'll put both these equations equal to each other. Okay.
And find it.
Find T. So 20T equals 17.2 T minus 0.1 T yes. How much is T?
Can be 2 values.
Huh?
Can be 2 values.
No,
Maybe
no,
1
no.
minus or 1. So that's square.
If you get a minus value, it's not acceptable. You just take the other one. That's it. But you don't have to do this. This will go here, and you can cancel out 1T.
Minus 1.
Sir, I'm drafting that. Sir, no. Sir, 2.8.
Which to
28.
28 minutes, right? Okay. Clear? So 28 minutes. Okay, that queue will be cleared in 28 minutes. Okay. So the next thing is how many vehicles arrive in 28 minutes? Tell me. How many vehicles arrive in 28 minutes?
Who's the equation?
Yeah. How many vehicles arrive in 28 minutes? So NA at the rate 28. Okay, 403 vehicles, whatever. Okay, now I need total delay. Total delay was the area under the difference of the area under the two curves, right? Okay, now the arrival follows this curve, right? And the departure follows.
23.
Okay, so area under the curve will be an integral of this, right?
There is something wrong.
Huh?
Something wrong.
Yeah, I think so. I think so. Okay, So there's a value, there's a problem here.
If I wrote equation, it becomes 0.
What?
حتى المعادلة 20 خرجتنا.
What?
The 28
It is wrong.
80 ولا 20.
So, anybody else?
عرفنا.
عم بيعلن حليتها. اي والله عم بيعلن.
Okay, let us see here. Where did we make the mistake?
8 0 3 تصير 20 ناقص 17
2.8 بس بالماينس يعني.
بتصير أنا كتير بتروح كتير 20
Anyway, I will check it. Okay. They did something here. I will check it later on. Okay, pay attention. Everybody. Okay. So, all of you. So, we are actually at this step. I will check what they did here. There's some difference here. Okay, I will check it. But anyways, we are here. Okay. So we have the equation for the arrival. We have the equation for the departure. We know how much time was the queue was. How long is the queue? Okay. The values are different. I know. We know how long is the queue. Okay. The equation for the equation for arrival is this one. When you take the integral of this equation, you will get the area under the curve. So I will take the integral of this equation, that equation. Okay.
And the integral of.
And the integral of the other one. Okay. But the integral has limits because I know after how much time the queue will be gone. So I don't want the full area. I want area up to only this much time. The time which you calculate for the queue. Okay. So take the integral with the limits 0 to this time. Okay, 0 to this time. Okay, for both equations. Okay, and then you take the difference. This will give you the total delay. And if you want the average delay, you will take this value and divide by the number of vehicles which you got after. Yeah, divide by the number of vehicles which arrived during this time. Okay, so if your time is 33.6, you will put 33.6 here. You get how many vehicles you got. So, delay from here divided by the number of vehicles you got from this equation for this time. Clear? Okay, I will check with what they did here. Okay, but let me summarize. There was the gate which processes the vehicles at 20 per minute. Okay, and the arrival rate was given as lambda. So first of all, what we did, we took the integral of lambda to get the number of vehicles arrived. Okay, and then for the departure, we have the rate multiplied by t gives you number of vehicles departed. Okay, we put both of them equal to get the time of the queue. Then for that time, we calculate how many vehicles arrived. Okay, in that time, how many vehicles arrived. Okay, then you take the integral of both equations, arrival equation, the departure equation, to get the area under the curve, but not the total area up to that time. Okay, then you take the difference divided by number of vehicles will give you average delay. Okay, the procedure is given here. You can follow it for the other gate. This is for the priority gate, which was at 20 vehicles per minute. For the other gate, only 20 was changed to 15. 20 will change to 15. Okay, clear? Yeah, one more thing, James, sorry. The gate opens at 6 and the T starts at 5:45. The gate opens at 6 and the T starts at 5:45. Okay, so you cannot do 20 into T because T is from 5:45.
Yes.
So the rate will start at 6 a.m. So whatever the T is, you have to subtract the 15 minutes, the first 15 minutes, from 5:45 to 6. Okay? For the non-priority gate, 20 will be 15. The rest of the things are same. You can even use the same equation as well. For the arrival, you can use the same equation. Clear? Only this will change to 15 and the rest of the things will change. Clear? Okay, I will see what they did with the first one, the first integral.
They subtract the priority.
Ah, yeah. It was 80%, yes. Okay, so sorry for that. This equation is for the non-priority gate. Okay, so this is the general equation, then you subtract the 20% who will go from the priority gate slowly. Okay, so this is the difference. Thank you.
Take 3 minutes more.
Huh?
Take 3 minutes more.
I will. Now your class is in this building, right? Yeah, but
Told you already.
you can go, no problem. You can leave, no problem.
حقت ما حقت
هاي سهل
Hmm? You are Hussain Muhammad, right?
Ibrahim.
I know.
Thank you.